can actually answer questions about the universe that we see when we look into the night sky. But there are still mysteries that remain to be solved.
SPHEREx and PUNCH are two completely different missions that are sharing a ride together to space. SPHEREx is a telescope that takes images of our skies in infrared. We're going to take thousands of pictures forming a map of our universe.
We're trying to look back in time to see what happened in the first second after the Big Bang.
PUNCH is a constellation of 4 small satellites. It's focused on the sun's outer atmosphere, the solar corona, and how that solar atmosphere fills our solar system and bombards Earth's magnetic field.
It's going to be the most complete all-sky survey that we've ever done.
Being able to see basically back in time, it's cool. It's like time travel.
We can expect some surprises in this process.
Together, SPHEREx and PUNCH highlight NASA's mission to not only explore the cosmos, but to unravel the deeper connections that bind us all.
3, 2, 1, and the liftoff. Here's a live look at the Falcon 9 rocket that's set to launch in just 53 minutes from Vandenberg Space Force Base. This one launch is carrying 2 missions. SPHEREx, a space telescope that will map our cosmos, and PUNCH, 4 small satellites that will study the sun's outer layer. Hello and welcome to Vandenberg Space Force Base in California. I'm NASA's Raquel Villanueva, bringing you live coverage from the
Hear his voice here. You know, again, weather, we expected that to be a watch item, but 20 minutes ago we got that weather briefing. Mick, who else are we going to hear reporting out to Dr. Gibson?
Yeah, so NOM will be checking with the teams from the NASA side to make sure that the rocket and the spacecraft look good for launch. He'll be checking with engineering, mission management, safety mission assurance, the spacecraft, of course, and our program to make sure that everybody's good to proceed into propellant loading on the Falcon 9. So we'll get ready for that poll here in about 20 seconds, and we'll hear the NOM poll that team to make sure that we can get into propellant loading.
Again, a beautiful shot of the launch pad at Vandenberg Space Force Base.
Great sunset view. We might get a nice twilight at launch tonight.
Yeah. And there you have it at the top there, the payload fairings with our 5 spacecraft on top. We have SPHEREx, that's 1 spacecraft, and then PUNCH is comprised of 4, so 5 spacecraft inside the payload fairing there. Again, we're standing by for the NASA Launch Manager poll.
Okay, I'm going to talk as loudly as I can.
A look at the clock, 42 minutes, 8 seconds from liftoff.
Stage 2 CCAM and the PUNCH spacecraft, and I looked back at the link margin analysis, and we do have the backup station.
It's a vehicle which is on the pad right there on your screen. Falcon 9 is a 2-stage rocket. It is the first and currently the only orbital class rocket capable of reflight. Starting at the top of the vehicle is the payload fairing, a protective shell that encases the payloads being sent to space today. Now, made up of 2 halves, the fairing will separate from the vehicle once Falcon 9 has climbed out of Earth's dense lower atmosphere. And today's fairing halves are brand new and will be flying for their first time. They'll be retrieved by our recovery vessel, Go Beyond, after launch. Now continuing down the vehicle, we have the second stage. The second stage is powered by a single Merlin vacuum or MVAC engine, which is optimized to perform in the vacuum of space. Below that is the first stage, which contains 8 engines arranged around one center engine, all of which are held in place by a structure called the octaweb. Now each of these 9 Merlin 1D engines delivers about 190,000 pounds of thrust at sea level.
The launch sequence has started,
which gives Falcon 9 a combined 1.7 million pounds of thrust during liftoff. The Falcon 9 first stage is also equipped with 4 landing legs that deploy to allow for a vertical landing on a drone ship or landing pad. And the booster supporting today's mission is flying for its 3rd time tonight, having previously supported NROL 126 and Transporter 12. After stage separation, the first stage will head back to Earth, this time targeting a landing at Landing Zone 4 at Vandenberg.
Space, and every once in a while they will impact a small dust grain. And when a water molecule collides with one of these dust grains, it freezes on the surface. It doesn't leave the surface. And these ice-covered dust grains participate in the collapse to form regions where new planets are formed. SPHEREx, for the first time, will allow us to directly measure not just the location of these key ingredients, but the abundances of these key ingredients.
We expect to have spectra of order 500 million galaxies, hundreds of millions of stars.
We will really see anything that is observable in near infrared, and that's a lot of things.
And so we can expect some exciting and unusual discoveries that come from this. SPHEREx is a nice complement to future telescopes, such as the James Webb Space Telescope, with the fantastic spatial and spectral capabilities, and learn more about what's going on.
Now, Farah, what are you most excited about?
I think it's going to be turning that instrument on, getting those first pictures, and really it's going to be the twinkle in the scientists' eyes when they get that data and make those big decisions.
Artemis Moon Minute. Scan the QR code on your screen to learn more about the upcoming Artemis 2 launch and what's planned for our Moon to Mars program. And it's been a busy week on the moon for NASA's Commercial Lunar Payload Services Initiative, or CLPS, where we've been delivering payloads to the lunar surface ahead of future Artemis missions. On March 2nd, Firefly's Blue Ghost Mission 1 successfully landed on the moon, carrying 10 NASA science and technology instruments. They are the first commercial company to execute a successful soft landing on the moon. And Farah, take a look at that beautiful video.
Such a cool video. I think I've seen it 10 times.
And just last week, Intuitive Machines' IM-2 mission achieved a historic feat, the southernmost lunar landing and surface operations ever. Although the IM-2 mission ended prematurely due to the lander's orientation, the data collected will provide invaluable insights into this challenging lunar region. And Farah, how about we answer some more of those SPHEREx questions coming in? All right. We have one actually that talks about the launch window and the times that are being heard. Can you explain what 8:10 and 8:09 mean?
Yes, I think we've talked about this a lot, right? So we are trying to target a particular orbit, and in order to do that, we need to launch at a specific time, and we have to launch between 8:09:57 and 8:10:27. So it's that 30-second window in which we can launch. So what we did is we looked at, okay, a few hours ago we looked at, okay, is there any collision risk? There weren't. And so what the team did is they decided to launch right in the middle of that window. That's really the optimal time to get right on that orbit. And that's why you heard us say that we're launching at 8:10 and 12 seconds precisely. And that's going to be our launch time today.
Fantastic. And thank you to Luke for that question on Instagram. Luke C on Twitter, on X actually. And we also have Rob V on YouTube who wants to know, how long will it take to map?
So the prime mission for SPHEREx is 2 years, and during that time we're going to take 4 full maps of the universe. And so that's really the amount of time that we want to spend, but there is no propellant on board the SPHEREx. There's nothing that we're going to, that's going to deplete over time, so we hope that the mission is going to last much longer than that.
Well, thank you so much, Farah. Keep those questions coming using the hashtag. Hashtag Ask NASA. With Falcon 9, second stage locks loading about to begin. As you just heard, let's send it back to Megan, Mick, and Jesse.
Welcome back to SpaceX in Hawthorne, California, where Megan, Mick, and I are just outside of Mission Control.
Yeah, and Jesse, SpaceX started fueling its first stage about 20 minutes ago. So how's that looking right now?
Yeah, we're a little bit over halfway done. RP1 loading is already complete on the second stage, and we're just about 80% complete on RP1 for stage 1, and about 60% complete of liquid oxygen loading on stage 1. And we are just about to start loading liquid oxygen on stage 2 at the T-minus 16-minute mark, which we should hear a call out for that in a few seconds.
Again, a great view of the rocket on the pad there. And at the tippy top, we told you that that is the payload fairings. And inside are the spacecrafts, which were encapsulated inside those payload fairings last week.
Yeah, and as Jesse mentioned earlier, talking about the Falcon 9 rocket, those are brand new payload fairings, and SpaceX will retrieve those with their recovery vessel Go Beyond. Inside that payload fairing, we have SPHEREx, our primary mission, which is 1 spacecraft, Punch, which is made up of 4 spacecraft. So deployment tonight, we will see 5 spacecraft deploy into a sun-synchronous orbit.
Now, we were saying that the propellants are RP1 or rocket-grade kerosene and super cold liquid oxygen. You know, why those fuels and how do they launch a rocket?
Yeah, Megan. So RP1 is the
here.
Oh my God, my heart is beating so fast. I'm so excited.
So I know we are going to talk to you more about that in a minute, but we've also been taking your live questions tonight. So let's get to a few more.
Okay,
right?
let's do it.
Okay.
Just
so
distracting me.
I know. We have one from Stardom Observatory on YouTube who asks, how long do you think it will take before we get the first images from SPHEREx?
So today we'll be separating from the launch vehicle. We'll actually get the first bits of data, hopefully very soon after separation. Definitely the team is going to be working through the night. And then we go through a commissioning period. So we'll take a few days to make sure everything is good. Then we'll power on the instrument. So it's going to take a little while, but we hope that that commissioning period will take about a month to 6 weeks. And then after that, we'll be moving into the real science. But even during that commissioning period, we'll be getting some images too.
It'll be great to see those first images come in. So keep those questions coming using the hashtag AskNASA. And Farah, launch is just minutes away now, so tell us how much this moment means for you and your team.
You know, I've been on this mission for about 3 years now. I saw the spacecraft grow from, paper design to being built and tested. We shipped it then from BAE Systems in Boulder, Colorado over to here. And now we've spent about 2 months here processing. We're getting ready for launch. It's really, really a big moment. And, the team has gone through such difficult times with the fires recently in LA, COVID, right when we were designing the spacecraft. So I know everyone is extremely proud and really excited to be here today.
And where were your team watching tonight?
So we have a lot of our team members in this building here at Vandenberg Space Force Base looking at the data, participating in those polls. We have people at the SpaceX building, and we also have part of the team at JPL at the Mission Operations Center, because once we launch, they will be the ones taking over operations, and they'll be working there through the night, taking care of the spacecraft.
All right, well, Farah, we are now under 9 minutes until liftoff of SPHEREx and Punch on a Falcon 9 rocket here at Vandenberg Space Force Base. Now let's head over to SpaceX Mission Control in Hawthorne, California, where our team of NASA and SpaceX commentators will count us down to liftoff.
Thanks, Raquel. If you're just joining us, I'm Jessie Anderson, a senior production manager here at SpaceX, and joining me are Megan Cruz and Mick Waltman from NASA.
Thanks, Jessie.
Yeah, the three of us have been commentating through the launch countdown, and we're going to continue to do that for about an hour after liftoff to show teams deploying the SPHEREx and Punch spacecrafts into space.
Yeah, SpaceX started fueling the Falcon 9 at about T-minus 35 minutes, and things are looking really good as we load propellants. We should hear a call out here soon as we get ready for engine chill at about T-minus 7 minutes. Engine chill is where we flow a small amount of that liquid oxygen into the engine to prepare for full flow at the cryogenic temperatures that the Merlin engines will see.
Yeah, exactly. And after that, stage 1 will wrap up RP1 loading around the T-minus 6 minute mark. Then stage 1 liquid oxygen loading will wrap up at T-minus 3 minutes, and stage 2 at T-minus 2 minutes before launch. And we are coming up on that T-minus 7 minute mark that Mick mentioned. Stage 1 engine chill coming up here in a couple seconds.
Chill.
Perfect timing. There's that call out for engine chill.
All right, so the SPHEREx spacecraft will collect a treasure trove of new information about hundreds of millions of celestial objects. And then you have PUNCH, made up of 4 satellites that will study the sun and how it creates space weather that can significantly impact us on Earth.
Yeah, all 5 spacecraft are packed inside that payload fairing that you see on top of the Falcon 9 rocket. LSP is keeping a close eye on those spacecraft with the spacecraft customer, and they will be transitioning to spacecraft internal power as we complete about T-minus 5.
Stage 1 RP1 load is complete.
All right, there's a call out for stage 1, RP1 load complete. We still have a little more loading left to go. They have to finish loading liquid oxygen into both stages, and there's about another 4 minutes left of that. But again, you know what we're not tracking?
Spacecraft is on internal power and configured for launch.
Well, that's a good call out there, too. That's Denton Gibson, Dr. Denton Gibson, again, NASA's launch manager, confirming that the spacecraft are on internal power. Can you talk to us a little bit about that, Mick?
Yeah, SPHEREx and PUNCH on in battery power, getting ready for launch tonight. I'm sure Farah is sitting at the desk just excited for this milestone as the spacecraft are now getting ready for launch later this evening.
And so flying both SPHEREx and PUNCH on one rocket, I mean, it just saves money. It's a great opportunity.
It's very efficient to be able to take advantage of one rocket and the multiple launch opportunities we can get and get 2 spacecraft with same science into the same orbit.
Yeah.
And excuse some of those loud sounds. We are actually in the factory here in Hawthorne, so you may hear some work happening behind us. And coming up, a couple things are going to be happening back to back. We have the transporter erector, which is also known as the TE or the strong back. It will start retracting away from the vehicle, and that's that large...
Falcon 9 tanks are pressurizing for strong back retract.
Good call out there. We're pressurizing in preparation for that strong back retraction. Again, that's that transporter erector, that structure there on your screen right next to the vehicle. It provides propellants and electricity to the rocket until just before launch. And we will first begin to see the clamp arms, which are just below the fairing, begin to open up. Once those clamp arms are fully open, then the TE can retract away from the vehicle.
Strong back retract has started.
There's that call out that it has now begun. And so we will see those clamp arms begin to open there on your screen. It'll be very slow and slight. But once again, once they are fully open, then the TE can recline just about a couple degrees away from the vehicle. And there you can see those clamp arms moving.
NLM, this is LD on Countdown Net.
This is NLM.
The NLM providing the status that the Falcon 9 is healthy and we're tracking no issues heading into launch. Can you provide a final verification status for your team?
NASA's go for launch.
Great, thank you.
And a quick poll there. It sounds like we are go for launch. And you can see that transport erector moving away from the vehicle. It'll be just 2 degrees. And then we can start pressurizing the vehicles coming up here shortly. But propellant is still loading on the vehicles. We're coming up on T-minus 3 minutes where liquid oxygen loading on stage 1 will complete here shortly.
Yeah, Jesse, as we said earlier, this is the 3rd flight of this booster for the Falcon 9 rocket. Those brand new payload fairings that will be retrieved by Go Beyond downrange. Inside those fairings, as we just heard from the NLM, everything is go. The spacecraft are on internal power. Both SPHEREx and PUNCH are healthy, and we are ready to proceed to launch tonight.
Stage 1 LOX load is complete.
All right, and all that's left now is to finish loading liquid oxygen into the 2nd stage. Again, we're targeting exactly 8, 10, 12 seconds for liftoff here from Vandenberg Space Force Base. Again, a beautiful wide shot right there of the launch pad. We'll stay with you until we deploy both SPHEREx and PUNCH in a sun-synchronous orbit around Earth. 2 really cool missions. Again, SPHEREx will deploy first, starting at about 40 minutes after launch, and then PUNCH's 4 spacecraft will deploy about 10 minutes after that in 2 batches. Now, as always, we're hoping for some great live views of all those deployments. Next call out we're expecting, again, in less than 10 seconds, that stage 2 LOX loading is complete.
Stage 2 LOX load is complete.
And there's that call out. Stage 2 liquid oxygen loading is now complete, which means that propellant loading is now complete on Falcon 9. That means 1 million pounds of kerosene fuel and liquid oxygen are loaded on the vehicle. And gas closeouts are in work now, and you can see some of those white clouds on your screen. That is us venting out the liquid oxygen lines from the transporter erector, and when that cold gas meets that warmer ambient air, it turns into condensation, almost like what you see when you get condensation on a cold glass of water. We're coming up on T-minus 1 minute, where the internal flight computers will take over the launch countdown.
Falcon 9 is in startup.
And there we heard in startup. So next up will be the go from Launch Director for SpaceX. This means that Falcon 9 will be ready for liftoff. Let's get ready to hear the go from SpaceX Launch Director for launch tonight.
LD is go for launch.
And there we hear the LD is go for launch, targeting a T0 at 8:10:12.
T-minus 30 seconds.
Range is go and weather is go.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff of the Falcon 9. Go SpaceX, go SPHEREx, go Punch.
SPHEREx and Punch on their way to map out our universe like never before and revolutionize space weather forecasting.
T plus 30 seconds into flight, and we are currently firing all 9 of those M1D engines. And after about 50 seconds, we'll begin throttling down those engines, which slow the vehicle down just slightly in order to prepare.
Power telemetry nominal.
In order to prepare for passing through max Q, and that is maximum aerodynamic pressure. That's the largest structural load that the vehicle will see during ascent, so slowing the vehicle down.
Vehicle supersonic.
Slowing the vehicle down will reduce some of the loads that it experiences through max Q. That's coming up here in a few seconds.
Max Q.
Right on time. And now we have a few events that are coming up in quick succession, so we want to lay them out for you really quick. It's going to start with main engine cutoff. That's MECO, and that's when SpaceX shuts down all of its 9 engines on its first stage, which we are getting a great view down the pipe right there. Shortly after that, Stage 1 and 2 will separate from each other, and then seconds later, the first stage will flip back towards Earth, while the second stage will continue on, igniting its MVAC engine. Now that call out is Second Engine Start 1, or SE1, and this burn will last about 6 minutes. After that, the boost back burn on the first stage to put it back on a trajectory towards landing zone 4, which again is back here at Vandenberg, just about 1,400 feet from where Falcon launched from in the first place. Wow, look at that shot. All Merlin engines firing right there, and we have such a great live shot of it.
Main engine cut off.
Stage separation confirmed.
MVAC ignition.
Stage 1 boost back startup.
Coming up next, we will see fairing deploy, and that's when the two fairing halves will separate and expose SPHEREx and Punch to the atmosphere of space. SpaceX will attempt, they will actually retrieve those fairings back downrange on Go Beyond once they get back to Earth.
Fairing separation confirmed.
There we hear fairing deployment confirmed, and what you see on the screen is the fairings separating and showing SPHEREx and Punch on their way to space.
Stage 1 boost back shutdown.
There you see on your screen and heard that call out that the boost back burn is concluding on the first stage vehicle. That's the first of 3 burns that it needs to make its way back down to Earth. This is the 3rd flight for today's first stage, which previously supported 2 other launches, NROL 126 in November of 2024 and Transporter 12 just in January of this year. And you may have noticed some soot on the vehicle prior to launch. During the entry burn, which is coming up here in a couple minutes, Falcon 9 is decelerating by reigniting 3 of the 9 Merlin M1D engines. Now, this causes the vehicle to fly through Merlin's exhaust gases, or the plume, which deposits a layer of soot on the vehicle's surface, and that soot comes from the carbon-based fuel that Falcon 9 uses. With each flight, the soot builds up just a little bit more on the outside of the vehicle, giving Falcon 9 its distinctive reused look.
We're just so lucky to have these great views. Again, we have a split screen here. On the left side is the first stage, and you see those grid fins. They're guiding that first stage back to a trajectory here at Vandenberg Space Force Base. And then on the the right-hand side on your screen, you have the second stage, and you see that MVAC engine is still burning there. You know, LSP just works really closely with SpaceX to be able to fly reused rockets for NASA missions.
Yeah, Megan, at LSP, we look at all the requirements for all the missions that we have. And as I said earlier, we selected SpaceX for the SPHEREx and Punch mission. And looking at all those requirements, we ensure that even previously flown launch vehicles will meet those requirements, providing NASA with a dependable and a cost-effective ride to space for this, our first rideshare mission.
Yeah, if you're just joining us, hello, we're in your bottom corner right there. I'm NASA's Megan Cruz, and with me is Mick Woltman with NASA, and also Jesse Anderson, a senior production manager at SpaceX. Now, Mick is with NASA's Launch Services Program, which is managing today's launch, so he's going to have a lot of interesting things to say to us to walk us through what we're seeing today. And of course, we have Jesse from SpaceX. Really great ride so far. We're so lucky to have you guys. And you know, LSP chose SpaceX to deliver SPHEREx and Punch to what's called a sun-synchronous orbit, 650 kilometers above the Earth. And SPHEREx is going to help answer some of the biggest astrophysical questions out there. You know, like how do galaxies form and evolve, how water and other key ingredients for life came to be. And then Punch is made up of 4 satellites that will study the sun and see how it creates space weather that can significantly impact us on Earth. I mean, Mick, we're talking about issues with GPS or satellites, things like that.
Yeah, it's
Stage 1 entry burn startup.
And there we heard the call for the first stage entry burn startup, looking for entry shutdown here in just a few seconds and getting ready for landing burn in just about a minute.
Stage 1 entry burn shutdown.
There we have Jesse, confirmed engine shutdown for the entry burn. But back to what you were saying, Megan, about the science of the mission. I know FARA is sitting there looking. We are so happy that we got liftoff tonight. But you know, the most important thing about these 2 missions is exactly what you were talking about. Once we get them deployed, the science that they will have to be able to help us here on Earth with some of the things you want. The spectral map of the universe will be incredible. And that solar wind and solar...
Stage 1 FTS has saved.
Flight termination system has been safe.
Stage 1
really
transonic.
And it sounds like stage 1 is on its way back. So that science is very important to us here on Earth. So we're looking forward to getting these deployed this evening.
We do have the landing burn coming up here in a few seconds. That'll be a single engine burn and the last burn that the vehicle needs to land.
Stage 1 landing burn.
There's that call out. Landing burn has begun. Let's watch as Falcon 9 touches down on landing zone 4E.
Stage 1, landing light deploy.
And such an awesome view of Falcon 9 touching down
Stage 1 landing confirmed.
on landing zone 4E, confirming the third landing for this booster.
We had applause here on the factory room floor. It's a fun place to see. You know, it would have been cool to see it at Vandenberg, but this was pretty cool too.
Yeah, I was going to say I love the launches, but you know what? I love the way SpaceX makes landing look easy
Stage
too.
2, SPHEREx has saved.
It's still one of my favorite parts, as many times as we've seen it.
And right there on your
back,
screen,
shutdown.
we lost the signal for a second, but basically we're keeping an eye on the second stage's first burn. That's continuing, and that burn's going to last until just after T plus 8 minutes. And then it will shut down. There will be a coast phase, and then we will relight a second time. All right, so again, first burn out of the way. We will see a second burn later. That's going to happen.
This is the clean room where SPHEREx is being built and tested. We call SPHEREx our small but mighty mission because it has some really ambitious science goals. The first is that we're trying to look back in time to see what happened in the first second after the Big Bang. We also want to understand how galaxies have evolved throughout history. And finally, we're looking for water and other basic ingredients for life in the places where stars and planets are forming.
BAE Systems partnered with JPL in the design and development of SPHEREx. BAE Systems was responsible for the integration and test of the spacecraft bus, which is everything below this metal ring you see around the center of the observatory. In addition, BAE Systems built the telescope that's at the center of the SPHEREx observatory.
The SPHEREx observatory is really two pieces. There's the bottom part that we call the spacecraft, and that's really the guts of the whole thing. It has the computer, the telecom system, the control system, the solar array on the backside, and then the top part is the payload. The payload consists of the telescope itself, the thing that takes the images.
The telescope is at the heart of how SPHEREx will observe the entire night sky.
And then these cones are thermal shields that help us keep the telescope cool.
The SPHEREx telescope and the detectors are required to be very temperature stable during their observations in order to collect that science data. And they lend this very distinctive structure to a spacecraft, one that I haven't seen before in my career.
So a spacecraft is built in the clean room, but we can't do all of our testing in there. We actually have different facilities that help us mimic the different environments that the spacecraft is going to see in space. The first facility that we get to when we come out of our clean room is the thermal vacuum chamber. Here at BAE, it's called Titan. It's a special chamber where we can lock in the spacecraft, pull out the atmosphere, and mimic the vacuum of space. It also can mimic the hot and the cold of space. So if you can imagine when SPHEREx is on orbit around Earth, it's going to see the sun, but also eclipses, so it gets really hot and really cold. And we can mimic all of that in that special chamber. Down the hall over there, beyond the curtain, are 3 more facilities. The first is the Fiesta area. That's where we do our acoustics testing. It's a whole big party for the spacecraft. We surround the spacecraft with these giant speaker stacks, and we blast sound at it, the same sound that it's going to see when it launches into space. Behind it is the vibration lab. That's a special table where we bolt down the spacecraft and shake it in all sorts of different directions, mimicking the shaking that it's going to go through when it's launching on that rocket. And then there's the electromagnetic interference and compatibility test. It's a really quiet room that absorbs all the sound, and we put the spacecraft in there and make sure that all of its components, they all emit radio frequencies. We'll make sure that they can all live in the same environment and they don't interact with each other in a weird way. There's one last test that happens here in the clean room, and it's called the separation shock test. What we do there is that we take the spacecraft and we mount it to the payload adapter ring. We then lift up the whole stack and mimic the separation that happens between the rocket and the spacecraft. When that happens, there's this big shock event, so we want to make sure that the spacecraft survives that and also that all the pieces fit together.
Years of hard work really paying off tonight, and this moment is so meaningful for the SPHEREx team and the institution of JPL. This year began with devastating wildfires across the Los Angeles area, including the Eaton fire that burned dangerously close to JPL. And Farah, hundreds of employees were impacted.
Yes, including members of our very own SPHEREx team. Some were forced to evacuate, and unfortunately others lost their homes. And it all happened right as we were preparing to ship the SPHEREx Observatory from Boulder, Colorado to Vandenberg Space Force Base. Many of us were right in the middle of final shipment preparations when evacuation orders started rolling in. We even had to change our transport route to avoid fires, heavy smoke, and road closures, something none of us had ever expected to have to plan for.
You know, and throughout the firefighting effort, JPL provided water resources and a helicopter landing area for firefighters. First responders and our community went above and beyond, helping those in need and working tirelessly to protect JPL and nearby homes. And we would like to thank them for their courage, dedication, and support.
Yeah, I think this is exactly the time when our community really shines, and we're so thankful for them.
Absolutely. You know, and someone else we'd like to thank today is the director of NASA's Jet Propulsion Laboratory, Lori Leshin, and she joins us now. Lori, it is so great to have you here.
Go SPHEREx! It's so exciting, and thank you for that wonderful opening about our first responders and our whole brave community. It's really special.
Absolutely. And Lori, this launch is a true bright spot for JPL's family. How are you feeling after watching that launch?
You know what? It's such the culmination of the hard work of so many people over many, many years. And even up towards the end, we have had quite a launch campaign here with lots of stops and starts. And when you're outside and are able to see that rocket go up, and this one, it flew right through Orion's belt. Oh, gorgeous. It just makes it all worth it.
Yeah, you could feel the rumble here too.
Oh my gosh.
And you know, SPHEREx is a great example of a smaller, more focused mission with incredibly ambitious goals.
Yep.
How do missions like these fit into the bigger picture of what JPL does?
Well, at JPL, we're really all about cutting edge science, no matter what size the spacecraft it is, right? We do big science with big missions like Europa Clipper and the Perseverance rover, but, and SPHEREx is an example of doing really big science in a somewhat smaller mission. And so it's just great to see when there's the right kind of science question, we build the mission to answer it.
And SPHEREx is also a collaboration between multiple partners. Can you explain to us how that led to the mission success and maybe how that might influence future collaborations?
Absolutely. I always say, you know, cosmic teamwork makes the dream work here, right? So collaboration is key to everything we do, whether it's with universities across the country and around the world, like we've done on SPHEREx. We have international partner Korea involved in the SPHEREx mission, and of course our industry partner at BAE Systems and the PI at Caltech. So it really is taking the best from lots of different organizations, and that's why our motto is Dare Mighty Things Together, because everything we do is about the team.
Well, thank you so much for joining us today, Lori. We appreciate you having you here with us.
Sitting next to me here are what we call our solar stones, and although we did not originally create the images depicted on these tablets, we replicated them from ancient petroglyphs down in Chaco Canyon National Park that were created around 1,000 years ago by the ancestral Pueblo people there. So this over here is the final version of our tablet. And it is a depiction of what we believe is a total solar eclipse around the year 1097. And the reason we believe that is because looking at this, it has all the telltale signs of an eclipse. It has an occultation in the center, where the moon would be blotting out the sun, this very circular shape. It has the solar corona out and along the sides, and up here on the top is what is believed to be a reflection of Venus.
While these tablets would be really good for any learner, we collaborated with the Colorado School of the Blind so that we could make these tablets accessible to low vision learners.
Space is typically a very visual field. You look up at the stars, you look at pictures of space, but if you can't see that, then you're pretty much completely blocked out from being able to study this and be able to understand this part of history. And so this way we have an exhibit that people can learn from if they are sighted or not sighted.
It took a lot of time to figure out how much detail we needed, how deep the objects needed to be, what textures we needed to use. A lot of these things that we didn't expect, we gained context through lots of user testing. So I think this project is really valuable because it allows people to interact with space in a completely different framework.
Every person has something they can contribute to the study of space. And so our hope is that not only can the blind and low vision community be included in this part of history, but that sighted learners can potentially learn things easier with a tactile experience.
Well, those solar stones are so cool. And with us now is Punch Principal Investigator Craig DeForest. So glad you could join us, Craig.
Thank you for having me.
And I see you brought some examples with you today.
I did indeed. So Punch is studying the sun, astrophysics at home, right around us. And in that, we're carrying on a tradition that goes all the way back to the ancients. So this is a 3D printed representation of what may be the oldest representation of the solar corona in a durable medium. This was recorded life-size, it's this large. Somebody about 1,000 years ago chipped this into the rock right near what is now the visitor center at Chaco Canyon. And this is consistent with, and many believe it to be, a representation of the solar eclipse of 1097, which occurred over Chaco Canyon. People actually witnessed it and observed the corona around us. So that ties us from the ancients to the modern esoterica of spaceflight.
And why was it important for Chaco Canyon to be the location for the Punch mission solar stones?
So we organized our outreach program around ancient and modern sun watching, and Chaco was a large center of culture about 1,000 years ago. The folks who lived here at that time had a long history of science, the technology that they had in hand, and of observing the sun around them to predict their environment and their future in much the same way that we do today. Though of course they were looking for things like agricultural planting times and things like that. But that thread of human curiosity looking at the environment around us extends all the way to what we do at NASA today.
So speaking of what we do at NASA today, so Punch has a coronagraph that sort of mimics a solar eclipse, right? And that allows us to study the corona. Can you explain how that works?
Certainly. So normally we can't see the sun's corona or the much fainter solar wind that Punch will image. And the reason for that is the sky is too bright. The sun is very bright in the sky is very bright. We normally can't see the corona unless the moon blocks the sun out. When we're standing in the shadow of the moon, we can see around the planetoid to see the solar corona extending out into space. But that doesn't stop. That extends all the way out and washes over the Earth. So Punch is in space. We can, instead of the moon, apply a very carefully crafted piece of metal to cast a shadow on our camera and allow us to see the corona 24/7 around the clock.
Wow. And you know, we really appreciate your expertise. We have some Punch questions coming in for viewers. Do you mind if we answer a few right now?
Let's do it.
All right, let's see what we have here. We have Rosanelle Acosta on YouTube wants to know, how does the satellite improve our ability to predict phenomena such as solar storms and their impact on Earth?
So Punch will allow us to forecast space weather much better than we can now. Right now, we look at the space near the sun, the corona, and observe storms forming and leaving the sun. They streak out across the solar system at 1,000,000 miles an hour or more. And then we extrapolate all the way across the void to our planet. We don't have a way of measuring them in transit. So with Punch, we'll be able to track them in 3D as they make the entire journey to the Earth. So that's very similar to what we see if you saw the weather report earlier. We always look at those geosynchronous images of the Earth to track weather storms as they cross the face of the planet. We hope to do the same type of thing for space weather forecasting, where we can track the storms rather than just taking samples here and there.
Well, Farah loves weather forecasting now, so she'll be tuning in for that. Kelly on Instagram wants to know, why is Punch a constellation of satellites?
So Punch is a constellation because we want to look out from the sun in all directions, up to 45 degrees from the star. That's a 90-degree field of view. It would go from the horizon to the zenith. We had to get our spacecraft close to the ground stations because we wanted to radio a lot of data back to the Earth. that meant there was an enormous planet in the way. So we had to make the instrument as large as the planet to look out in all directions. The only way to do that was to mount it on 4 spacecraft.
Yeah, makes sense.
All right, Craig, thank you so much for your expertise. We really appreciate it. And we will be taking more questions later on the broadcast, so keep them.
Farah.
Thank you so much. Turning our attention back to SPHEREx, the Space Telescope is gearing up to map the entire sky like never before. With special photon shields and an ultra-cool design, here's how it will spot hidden cosmic secrets in infrared light.
This is SPHEREx, NASA's cosmic mapmaker. It will scan the entire sky, charting the positions of hundreds of millions of galaxies. But why does it look like my dog after his last visit to the vet?
These concentric cones help keep SPHEREx cool and shielded from nearby bright objects. Anyway, continue.
Ah, of course. SPHEREx has 3 cones, which are called photon shields. They block light and heat from the sun and the Earth. That's a big deal because without those shields, the telescope's detectors would be blinded. But SPHEREx also needs to be cold because it detects infrared light, or wavelengths slightly longer than what the human eye can see. Infrared is emitted by warm objects on Earth and out in the universe. It's also emitted by the telescope. Keeping it cold reduces the infrared glow, which lets SPHEREx see faint objects that are really, really far away.
That's right. These aren't cones of shame, they're SPHEREx's cones of fame. Here you can see one of SPHEREx's 3 cones being assembled. They sit atop this shiny jewel of a structure called a V-groove radiator. The mirrored surface directs heat out into space, cooling the telescope and the infrared detectors.
Cooling them to minus 350 degrees Fahrenheit. That is cold.
SPHEREx can help us study everything from what happened a few seconds after the Big Bang to where water comes from in planetary systems. That's why its full name is Spectrophotometer for History of the Universe, Epoch of Reionization, and ICES Explorer.
And I'm sorry, could you say that one more time?
You can just keep calling it SPHEREx.
And so I will. The V-groove radiator and the photon shields surround the heart of SPHEREx, the telescope. It's a feat of modern engineering, designed with incredible precision. And it looks tilted?
That's not a mistake. That tilt helps it see the entire sky while under the protection of the photon shield. Do you mind if I get back to work?
Sure, let's wrap this up. The cone of fame, the gorgeous jewel, the tilted telescope,